Okay, so now we will start with Bluetooth low energy, which is a trade-off for Zigbee, and Bluetooth trades throughout this short-range communication. So in this short-range communication, we always work in this short range communication. We always work on with more extreme energy constraints. One such extreme energy constraints is this Bluetooth low energy device, where it trades off with efficiently with energy boosters and a short range connection burst and sleep heavy duty cycles. So sleep heavy duty cycle and a native support in virtually every smartphone makes it difficult default one for consumer facing IoE devices, and all these devices makes a good sense of connectivity with Bluetooth low enabled protocols. And one such thing is this specification teach with 2.4 GHz ISM bandwidth with bits per second MSBs, ranges from 10 to 100 meters, and with the topology of point-to-point star mesh topologies, and data model CAT protocol, which over ADT protocols, and it is ultra low protocol session with 1 to 2 years of connectivity. And in Bluetooth low enabled devices in the real world, it actually goes with wrist one health tracking to indoor micro location, and here it is Apple Watch and Fitbit. It suggests an idea of how this works, that is streams the heartbeat step data to be paired phone with the CAT heart rate services, adversities intermediately, and connects only in a short burst to conserve battery for multi-day wear. And Nick Adidas runs beacons, that is BLE beacons broadcast an iBeacon AD stone identifier that a nearby app detects to trigger local aware notifications or personalized offers in the store. And all these things will give a detailed description of this retail stores, that is retail and sports stores. So these retails and sports stores gives things such as this Nike, Adidas run becomes, which has some idea of how to deal with low range communication protocol types, and followed by Amazon warehouse tags, where access tracking helps to create the idea of tracking Bluetooth low enabled tags and payouts with indoor positioning without GPS locational tracks. In NFC, that is near field communication, NFC uses inductive coupling between two loop antennas, that is these, and its centimeter scale range is a security feature, not a limitation, and a passive tag needs no battery, powered entirely by the reader's field. That is, it has a frequency of 13.56 MHz RF18 derivative, and followed by a data rate, that is 106 to 242 kilobits per second, with a range of up to 4 to 10 centimeter, with a topology of from point to point. And we have some passive power source, that is passive tags, and reader powered no battery systems, where it all deals with some security checks, that is short range communication, tokenizations, and setup services. All these things are available. And NFC in the real world, that is start to connect the security through proximity. Here in this we have Apple Pay and Google Pay. So all these things are contactless payments. That is, contactless payments deals with the real card transfer, that is transitions, that is EMV transitions, and all these transitions will give some importance, that is card emulations and real transmission things and real scenarios and things, and smart posters and device pairings, marketing and setups. So an NFC tag embedded in a poster stores a small NDEF, that is NFC data exchange format message, typically an URL. Tapping a phone launches the link instantly. No apps are pairing needed. Speaker and headphone manufacturers, Sony Post uses NFC, that is touch to pair tapping, exchange Bluetooth credits, which gives automation of exchange of these device setups. And to say technically, we have a parameter range for all these Zigbee and Bluetooth and NFCs, and here we have some universal scale over, that is Zigbee, that is scaled over the speed. So best when you need hundreds of low power sensors that are self-organizing into a resident mesh, that is smart lighting and industrial monitoring. And here we have many idea of understanding of creating nodes as well as connections, as well as things that are more better in connectivity and more resilient in match. Here we have a suggestion of understanding this Zigbee protocol with few occasional changes and few things that are understandable and that are viable in frequency of Zigbee, and that suggests that we have a more inventive way of understanding things like having Zigbee protocol methodologies and Zigbee realistic changes and all these stuffs, and things that suggest more iconic way of understanding things. And well, as a universal bridge, that is best well as Bluetooth low enabled device, that is which best when a smartphone is hub and moderate data with long battery life that matters, the wearables and beacons, and we have some Bluetooth connectivity, low power enabled connectivity over these things. We have more importance in idea in understanding all these scenarios. We have smartphone features and understandabilities and things that more realistic in giving idea of how Bluetooth enabled device works. NFC, that is security through proximity, and here in security through proximity we have best for one touch high trust interactions like payments, pairings, and where the tab itself is an authentication. And here in NFC we have a near field configuration where security alert systems creates more importance in understanding things that are more viable and more realistic. And together we go with Zigbee Bluetooth NFC form, where short range of communication of IoE is possible, and each optimized for a different point and the range, power, and data rate spectrum. So all these steps gives information of how to deal with short range protocol types.